Hi students. So today we are going to start the new chapter of the class 10 science, that is periodic classification of elements. That is very important chapter. Okay, so in this chapter we are learn about how the elements are classified in the periodic table. So nowadays we observe the modern periodic table and total 118 elements are present in that periodic table. So how that modern periodic table is designed? Okay, so that is not a first modern periodic table. Actually there are so many attempts are been done by the scientists to design a periodic table, right? So why we need to design the element, why we need to classify the elements in the nature, right? So in the starting of this attempts, we observe that a few amount of 50, 40 or 56 elements are be discovered. So many scientists are they try their attempts and they are try to solve this classification, right? So there are so many elements are there, and every element having different physical property, different chemical property, different atomic number, different atomic mass, and then different electronic configuration. So they are different, but they have to classify them in the systematic and orderly manner. Okay, so many scientists are here attempt on the classification of the elements. So slowly we classify the elements according to their chemical physical properties, and finally we get a modern periodic table, right? So in this chapter we learn all those attempts, all those history of the classification, how the scientists are classify some elements according to their some principle, and how the some laws are fail one by one. Okay, if anyone scientist can classify the elements, after some years that principle and that classification is failed. Okay, so there are so many attempts are there. So let us start this video with some basic information about that history of the classification. Let us, so first basic concept, basic question is that classification of significance of classification. So significance means importance. Okay, so what is the importance of classification, right? So we classify the elements, right, according to their atomic mass. Okay, in the nowadays, but in the first attempt they can classify according to the increasing order of atomic masses. So that all efforts are there in the classification of element. Why they require that efforts? Okay, why we need to classify? So that is importance of classification of elements. So simple answer is help to analyze and understand the properties of the element very effectively, right? So that is very important. With help of the classification we are what understand and analyze the properties. Okay, analyze the elements, analyze there is a link between the each element. So that is what we required. So that is why we classify in the metal and non-metal and noble gases. That is nothing but classification. Okay, so we know that metal having some property, non-metal having some property, and noble gas having some property. So that is what these all three category are having function. Okay, they are analyze the function, analyze the difference between metal and non-metal, difference between metal and the noble gas. Okay, that all analyze and understanding, that easily done by with help of classification. If the elements can be orderly, effectively can arrange in a table, then easily we can recognize and easily we can remember the about the elements, their property and their reactivity. Okay, so that is what important significance of classification. So examination 1 marks question, write the importance of classification of elements. So simple answer, significant important, that is to help analyze and understand the properties of the element very effectively. Okay, that is what very important. So how we classify the elements, that is what orderly. Okay, orderly. Okay, in order we can arrange the classification of elements. Okay, so in which order, what principle all follow to make order, so that all be next points. Okay, so let's see, there are several attempts are make for the classification of element. There is no one attempt, no two attempt. There are several attempts, are several scientists are try to classify, to solve this problem. Okay, to classify the elements. So we have say that several attempts, not one, two, more attempts are there for the classification of the elements. Okay, so in this classification of elements, the first try by the classification, that is a Dobereiner triads. Okay, Dobereiner, scientist name Dobereiner. Okay, he get traits means his table, right? So first scientist who attempt in the classification of, okay, who got interest in the classification of element, the first scientist is Dobereiner. Okay, so in this video we are learn about Dobereiner statement. Okay, which principle is used by Dobereiner and how on which principle, on which knowledge he can be design a classification. That is Dobereiner classification we learn here. After some time this classification is failed. How, why, what are limitations, that also we learn, right? And next we learn about the next scientist after the failure Dobereiner. Okay, failure of Dobereiner, the next scientist Newland is there. Okay, so Newland is also try to solve this classification. So second scientist Newland, and also after some time this Newland theory also failed. Why? Because of some limitations we learn in the later classes. And then next third one is Dmitri Mendeleev. Okay, Dmitri Mendeleev also be classified, and most he nearly successful about that. Okay, most important theory is what? Dmitri Mendeleev theory. Okay, he is nearly successful in the classification, but after due to some limitation this theory also failed. Okay, why? It is all be in next class. And next last one is a Henry Moseley, that is nothing but modern periodic table. Okay, now we having the modern periodic table of 118 element, and that is designed by the Henry. In the last cover page of your textbook you observe the table, right? This is the Henry Moseley, that is modern periodic table, right? So these are what the different scientists attempt their different ideas. Okay, with their different idea, with their different principle, they can attempt in the classification of elements. Okay, so one is Dobereiner, one scientist, next Newland, next Dmitri Mendeleev, and next Henry Moseley. So one by one learn in this class. So first in this video we cover these two concepts. One is about Dobereiner traits, how the Dobereiner can be classified the elements, and then we learn about the Newland. Okay, so we can cover these two attempts. Okay, these two attempts of classification of element in this video. In the next video we can take these two concepts. Okay, so let us start with the first classification of element, that is first attempt, that is by Dobereiner. Okay, and the Dobereiner can design a table, and that table is called a triads. Okay, so let us one by one let a statement, an example of a Dobereiner triads. Okay, take notebook and take pen and make notes of this all concept, and next let us start with this point, that is what Dobereiner triads. Okay, so let us write down this one. Okay students, now take the first law, that is first attempt by the scientist, that is chemist Dobereiner's. Okay, Dobereiner, that is called Dobereiner traits, right? So let us know about Dobereiner. In 1817, okay, 1817, the full name is John Wolfgang Dobereiner. Dobereiner is an German chemist. Okay, German chemist. He can try to, okay, first attempt by the Dobereiner to classify the elements. Okay, let us see the statement given by the, okay, about Dobereiner. You see, when the three elements in and triads. So whatever triads here, see, triads nothing but Dobereiner are classified in one group, and in that group he can make three elements, right? This group, for example, take here, this is the one group. Okay, this is the one group, this is the second group, and this is the third group. Okay, this whole in this direction one group, it is one group, it is the second group, it is the third group. So in one group lithium, sodium and potassium, and the second group calcium, strontium and then barium, and the third group chlorine, bromine and iodine, right? So this is the, okay, and this group, one group is called as a triad. Okay, triad, right? So he can take triads. Okay, in one triad nothing but group. In one group he can take three elements. How he can take three elements, that is the next principle is there. Okay, so first point you have to remember, the Dobereiner make a triads with nothing but groups, and in each group having three elements, right? You that remember, triads nothing but group. Okay, triads nothing but what? Groups. Triad nothing but what? Groups. There are three groups. Okay, Dobereiner can be successful in the classification of three groups only. Okay, three groups he classify. Okay, three groups in classify, and in one group, how many elements? Three elements are there. Means three group, three means total 9 elements are there. So triads nothing but groups. Okay, and there are how many groups? Three groups are there, that is in this column. Okay, one column, two column, three column, three groups are there, and each one group having three elements. Okay, that one group is called a triad. Okay, so let us see, when the three elements in a triads, one means in a groups, are written in the, okay, we written L, I, N, A and K in the first group. Okay, first triad. How? By the increasing order of atomic masses. That is the principle. What is the principle of Dobereiner classification? That is the principle of Dobereiner classification, this principle. Okay, so in the examination maybe they ask, what is the principle of Dobereiner classification? So that is what? Increasing order of atomic masses, right? So increasing means smaller atomic masses to the heavy atomic mass, okay, lighter atomic masses to the heavier atomic masses, okay, that is what classification. So simple sentence. So how the Dobereiner classify the traits, elements, 3 elements, that is in the order of increasing order of atomic masses. You underline this point, okay. So that is first principle. So principle of classification is the increasing order of atomic masses, means that Li, Na and K is in the order of increasing order of atomic masses, right. Then the atomic mass of the middle element means what? See here, lithium, sodium and potassium, in this group the middle number is, this is the middle number, okay, this is what? Middle number. This is the middle number, right? This is the middle element, okay. So let us see the atomic masses of the middle number as roughly the average of the other 2 element atomic number. For example, see, let us see here, see, we know that the lithium, okay, the atomic mass of lithium is 6.9, okay, roughly we can take 7, right, 6.9. And then the atomic mass of sodium, I can make gap it, then at K, okay, the atomic mass of potassium is about 39. Yeah, how much? 39. So let's say according to this, we first write increase here. It is 69. It is 39. It is 6.9. It is 39 means increasing order. Okay, small to big. Let us see. The middle number, atomic number, middle number element must be average of these 2, right? For example, I turn to average of these 2, 6.9 plus 39. How much it is? Divided by 2 average. Okay. So see here, how much it is? 45, around 46, approximately 46. Okay, 46 divided by 2 means it is how much? 23. So this is what? 23. So 23 atomic mass is nothing but sodium, right? So that is what average. So see here, it is a 6.9. Okay, it is the 39.0 and it is how much? It is a 23. So we observe that the sodium atomic mass is the average of the lithium and the potassium. That is the statement here. See here, the atomic mass of the middle number. So middle number atomic mass 23, that is nothing but the average of lithium and potassium, right? So that is what you have to be remember point, very very important, simple statement. So first one is what? So 3 parts are there. First part is 3 elements arranged in a triads, okay, written in a triads. In which principle using? By using the increasing order of atomic masses, second point. And after that, about the middle number, about the middle element, okay, the middle element atomic mass is roughly, not exactly, we take roughly actually, okay, so 6, it is about 45% something, but we roughly take 23, right? So here see, roughly the average atomic masses of the other 2 elements, okay, extreme element, lithium and sodium. That is what he put sodium here, right? So we observe that when we take the average of lithium and potassium, we get answer 23. So 23 is the atomic mass of sodium. So he can put sodium here. So we get 1 triad. That is what? About lithium, sodium and potassium. And we observe that these 3 having the similar chemical and physical properties, okay, similar properties, chemical properties. So this is what successfully can be suitable in this one group, okay. So first group, first triad having which element? So Dobereiner first triad is lithium, sodium and potassium. Do you have to remember? Okay. So Dobereiner make 3 triads, 1, 2, 3. Okay. In one triad, 3 elements are there. And then first triad is lithium, sodium and potassium. And how it is arranged? So it is arranged in the increasing order of atomic masses, and then sodium atomic mass, the middle atomic mass, is average of the other 2 elements in that triad only. Okay, so this is one classification of element. Like that, he can use, he can add atomic number of calcium and barium, and average we get strontium. Okay, so again he can add the chlorine and iodine atomic masses, and average we get about barium. So like that, what happens here, we get one set of classification. Okay, so this is what Dobereiner first attempt and first classification of elements according to Dobereiner. So this is what Dobereiner principle or Dobereiner law. Okay, so it is called Dobereiner traits law, and this having the very important in examination. Okay, state Dobereiner, give example. Okay, state Dobereiner traits and give examples. You write this statement, and with this is the example. Okay, you can give this example for lithium and sodium, potassium. Okay, it become easy. Lithium having 69, 23 is sodium, and potassium is 30. 39. So we get average of lithium, sodium is potassium is 23. So that is what example. You can remember this triad. Okay, only 9 elements are there. Okay, one triad lithium, sodium, potassium, and second triad calcium, strontium. Okay, Sr means strontium. Okay, Sr means what? Sr means strontium. Strontium. Okay, Sr means strontium. Ba means barium. Okay, barium, and Ca means calcium, right? Calcium. So this is what Dobereiner second triad. Okay, this is Dobereiner second triad, and Dobereiner third triad is what? And Dobereiner third triad. Okay, this third group or third triad, the chlorine. Cl means chlorine, right? And then Br means bromine, and then I means it is iodine. Okay, this is what Dobereiner third. Okay, Dobereiner first triad is what? Lithium. Okay, that is Li, and then Na, that is sodium, and then is what about K, that is what? Potassium. So you have to remember all these points. Okay, so first remember statement and then practice or this memorize this table. First triad element, second triad elements, and third triad element. Try nothing but group, and one group having how many? 3 elements. How we arrange according to this statement. Okay, so increasing order of atomic masses, that is the principle of arrangement. Okay, that is the basic principle of Dobereiner classification is increasing atomic masses. Okay, this is very important, you have to remember. And then the middle is middle atomic mass is average of the atomic mass of other 2 elements. Okay, so that is very important statement, you to be remember, very simple one. But what happened after some years, this statement is false. Why? Because of Dobereiner is only successful in the classification of this element only 9 elements. But at that time nearly 56 elements are known, but Dobereiner can only successful in the classification of 9 elements according to this rule. Means what? Near 40 to 45 elements are not be match according to this rule. So what happened? So this stage is failed. Okay, that is failed. So I write here about the limitation. So limitation, that is failure of. Okay, we can take a failure or limitations, right? Or also say that drawbacks of the Dobereiner triads. Okay, so drawbacks nothing but not all known elements of that time. Means what? When in 1817 there are so many elements are discovered, but not all the elements can be classified according to this rule. Okay, some elements are not be able to follow this rule. So that is only some, that is what, only 3. Okay, only 3 triads he can make by using 9 elements. Okay, so not all known elements. Okay, not all known elements of that time are able to classify by Dobereiner. Okay, Dobereiner he only successful. Okay, only successful in the making of 3 triads. Okay, only 3 triads. 1 triad, 2 triad, and 3 triads. Only 3 triads by using 3 triads of including 9 elements. Only 9 elements are successfully classified by using Dobereiner triads, but the remaining elements does not be classified. That is what the big failure of classification of Dobereiner. So automatically this classification will be rejected by the chemist of that time. So that is what the failure of Dobereiner classification. So because of that, after the failure of the Dobereiner classification, the next scientist, that is Newlands, came here in this field, and is actually musician. Newlands is a musician. By using the music knowledge, he can classify the element. So how it is be happened? So after failure of Dobereiner, then the next classification about the Newlands octave classification. So let us see that one also. Okay, so please write down these all points about the classification statement, and then example, and then the limitations. Okay, then come to the Newlands octave rule. Okay, let us start. Okay students, now let us take the next one, second one, that is about Newlands laws of octaves. Okay, so there is Newlands scientist is there, he from English scientist, and in 1866. So first attempt 1817, and then after Dobereiner, the next after Dobereiner failure of classification, then 1866 the John Newland, a musician, actually he is a musician, if take interest in the classification of elements. Okay, so let us see what the idea behind his classification. So the statement is arrangement the elements in the order of increasing atomic masses. So same, the what is the principle of classification of, what is the principle of classification of Newland? That is nothing but same as per the Dobereiner. Dobereiner idea is about the increasing order of atomic masses, and that same idea is followed by the Newland, John Newland. That idea is what the basic principle of classification is elements in the order of, okay, how we arrange the element in the increasing order of atomic masses. Same point. Next is, see next, he stated that from the low, he started from lowest, okay, lowest at the mass, that is from hydrogen. So atomic mass of hydrogen is 1. So he start from hydrogen and end with the thorium, that is highest atomic mass, that thorium. Why thorium? Because 56 element, only 56 elements are known at that time. Okay, at the time of Newland only 56 elements are known, discovered, right? So that is why the first is start with hydrogen and end with what? So thorium. That is very important, you have to remember. So classification of element is based on the increasing order of atomic masses, and start with the hydrogen atom with the lowest atomic mass and end with the thorium. That is what 56 element, known element of that time ended. Okay, means what? He is involved in the classification of 56 elements, right? So let's see. He found that every 8 element have similar property that of the first one. So he compared this to the music of music. So in the music we observe that there is a these are scales are there. Okay, we in Hindi we say that sa re ga ma pa dha ni sa. Okay, so see, observe the first sa scale and the 8th again both are sa and sa. That is what? Sa re ga ma pa dha ni sa. Again the 8th key is again matched to the first key. That is the first key also sa and the 8th key also sa. So that is he compare like that. So when we take the element counting here, for example, I take count from the hydrogen. So hydrogen is the 1. So see here 1 2 3 4 5 6 7 8. So you observe that every 8 element is similar to that of the first element. So observe that the hydrogen and fluorine, hydrogen is 1 and the fluorine is 8, means if H and F are similar, so he can make in them one group. Okay, he can put H below fluorine. Why? Because of the, according to this rule, say every first element is similar to that of the 8 element. That is what compared to the music octave, and this is true, and actually this is true. His assumption is very much true. He compared that with the music. So music nothing but 8 scale, so that is called octaves. Okay, so called laws of octave, or also called as a Newland laws of octave. If I count start from here, okay, if I count anyway, okay, start the counting, you get a similar property. For example, I count from the lithium. So what happens? See, 1, I count from lithium 1 means it is 2 3 4 5 6 7 8. See, observe again lithium sodium are similar, because in the table we observe that lithium, sodium and potassium, this is what first trade of Dobereiner. So see, observe that it is matched. So fifth I count from here 1 2 3 4 5 6 7 8. Again sodium potassium matched. So that is what, this is true, right? So we observe that every first element and the 8 element, right, that is what similar chemical similar properties, right? So he can arrange like that table. So first he can take first arrangement is increasing order of atomic masses. After that he can put the every 8 first element and the 8 element is similar in their properties. So that is called as octaves of music, and that is nothing but what? Newland octave, nothing but 8. So Newland laws of octaves. That is what about the classification of the Newland's law. Okay, Newland's law of octaves. So this statement, so again I repeated, so statement having again 3 parts. One part is about the first principle, increasing order of atomic masses, and the second part is about starting, okay, from hydrogen to and with the thorium 56, second part, and the third part is about the nature. That is what found that every 8 element is similar to that of the first element. Okay, so Newland observed that every 8 element is similar to that of the first element, every 8 element is similar to that of the first element. It is compared to that of the music octave, and this is called as Newland law of octave, and this is what the Newland arrangement, right? This is what a Newland arrangement. Okay, so sodium, so this is one group, this is the second group, third group, fourth group, that is different group according to the arrangement by this statement. Okay, so Newland use the music octaves, and if successfully can, okay, his statement is true. Okay, up to calcium it is true. Okay, if I can take sodium, magnesium and calcium, it is true, but after the calcium the theory again start to fail. What means that if I count start from here, okay, here 1 2 3 4 5 6 7 8, but this silicon and tin is not similar. Okay, they're not similar. So here what happened, this theory is only pass, this theory is only true, that Newland concept is only true up to the calcium. That is what the big failure of again Newland. After the failure of Dobereiner, the Newland is discovered, and Newland law is also failure because of this property. That is what, not all the 56 element can be classified, only up to calcium is what, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, only 17 element can be successfully classified according to the music octave. After the 18 19 they not be follow this rule, they not be follow octave rule. So that is what, that is by big and first failure of the Newland octave. So we say that after failure of Dobereiner, the Newland classify, and also the Newland classification is also fail. The first reason is up to calcium this law is come. Okay, this statement, okay, this logic is holds good, but after the calcium this is now holds good. Okay, that is what the first limitations of the, right, this first limitation of Newland. So one by one we can take. So here also first element is, that is what failure is, this Newland is hold good successful only up to the calcium, and also we may observe that this cobalt and nickel are placed in a single one table. So that is what big question mark. Okay, why he put both in, there is no explanation. Okay, and again fluorine, chlorine and bromine, they are not matched to each other, they are totally different from each other. So that is what some difference is there, but they put in the same group. That is what, there is no expression for this one. See here, he can make here double, but why he can make here double, they see here also double calcium sodium, but why he can make in the one group, that is not be explained. So that is what the some of the failures of the Newland, right? So that is what we can take. So first write down this one. Okay, so write down this statement and then this table, and we come to the next one, limitations. Okay, that is failure of Newland. Okay, so first write down this one. Now see the limitations of the Newland octaves, law of octaves. That is, first limitation is applicable up to the calcium. Okay, up to the calcium this can be applicable. After the calcium, if you count, means they not be same property, they not follow the octave. So that is very important. Up to which element the Newland is old good, that is up to the calcium. That is very important. And next, properties of the Newland element could not be, okay, properties of the new elements could not be fit into the, okay, 56 element discovered at that time after the discoveries of new elements. Okay, after the nature we observe that after 1866 the new elements are discovered. Okay, but that new elements are not fit according to this rule. Okay, they match into this rule, and also they not give any gap to the new elements. That is what big problem, that mistake done by the Newland. Okay, that is new element is not to follow this rule. And next one is work only with the lighter elements. Okay, lighter elements means having low atomic masses. Up to that the elements can be whole good. For the heavier elements this octave is not successful. And next is some cases the properties of the elements are not the same as defined by octave. Means what, after the calcium, okay, after the calcium if I take or we take about the cobalt, nickel, or we take about after calcium, we observe that they not follow the any similar chemical properties or different okay, not a physical property, they are different with each other. So they put into the same group. That is what the big drawbacks of the Newland. So this is about the 4 limitations of Newland laws of octave. So because of these limitations, again this theory is also failed. After that the again scientist Dmitry Mendeleev's is their classification is there, but in the next video we can take about that Dmitry Mendeleev's classification. But for this video we can take 2 classification, one Dobereiner classification statement and then example and their failure of the theory, and then we take the Newland laws of octave and the limitations and that example and then the limitations and the failure of the Newland. Okay, so that is what 2 theory we read, but 2 theories are later on due to some limitations they are failed. So these are the two laws, two classification, two attempts of the classification of elements. In the next video we can take the next classification, next attempt made by the scientist. Okay, so this is enough for this video. In the next video with the another very important attempts. Okay, so thank you very much for watching this video.